right, so take a few minutes, work with the partner, or work on your own. See if you can get these figured out. I'll come back to, if you pause the video and work through this, I'll give you a couple hints. We're just missing this last number. So if this number is 2, what do we take 2 times to get 14? 7. Notice plus 2 plus 7 makes positive 9. So you're just trying to look at one side and look at the other side in between the ands. And fill in the missing blanks. All right, so we're going to get into polynomial division. So first let's start with just regular numbers, all right? Because it's probably been a while since you actually divided numbers by hand. Do you recognize a fraction bar? The division sign? They're the same thing. Okay, one's just written with the division sign, one's written as a fraction. This just means to divide, right? All right, so let's actually divide. Determine if 4 is a factor. So think about what makes something factor when we're listing all of our factors. Is there something times 4 that equals 256? So let's go back to old school. How do we divide by hand? Well, 4 can't go into 2. How many times can 4 go into 25? 4 goes into 25 6 times. Then 6 times 4 is 24. Then we subtract 24 from 25, bring down the 6, repeat the process. How many times does 4 go into 16? 4 times 4 is 16, and there's a remainder of 0. If there's a remainder of 0, that means 4 times 64 equals 256. If there's a remainder of 0, 4 is a factor. Yes, it's a factor. All right, what if we change 256 to 258? Once again, 4 goes into 25 6 times. 6 times 4, 24. Subtract, bring down the 8. 4 goes into 18 4 times. Subtract, and we get a remainder of 2. Because we're not going to do the decimal and all that other stuff. So if you get to your last number and there's a remainder other than 0, it is not a factor. And what we could do is just put this 2 over 4, and that's how you can write remainders. All right, so now let's move into a little bit easier, or polynomials, but a little bit easier than we're going to look at. Determine if x is a factor of this polynomial. So we're going to start with long division. X goes into x squared x times. X times x. See, I always put the factor over what it matches here. X times x is x squared. Then we subtract. This always drops out. Bring down 8x. X times what? You could also think of it that way. X times what is 8x? 8. 8 times x is 8x. When we subtract, we get a remainder of 0. So we know that x is a factor of this quantity because x times x plus 8 equals x squared plus 8x. Okay. Now, We could also try it this way. We could rewrite this x squared over x, x over x, 8 over x. And see how this reduces and this reduces, but this can't reduce. We have an extra piece. That's telling us it's not a factor. So let's look and see with our division how that would look with the remainder. So x, what do we multiply x by to get x squared? X, and take x times x is x squared. Subtract, it cancels out. Bring down x. X times what is x? 1. And I'm just putting this plus in there as a placeholder. 1 times x is x. Subtract 0. Bring down 8. See, we can't multiply x times anything to get 8, so our remainder is 8. This tells us it's also a remainder because it can't go in evenly. Okay, so now let's look at what the really important part is here. You always just start with the front pieces. What do I take x times to get x squared? X. X times, now I have to distribute all the way across. X times x is x squared. X times 2 is 2x. Now, I always say when you draw the line, change the signs. Because remember, our next step's always subtract. We have to subtract all the way across. You always should cancel out the front part. Now we're going to combine like terms. -1, -2, -3x. Bring down 8. And it's a -8, so bring the negative down with the 8. What do I multiply x by to get -3x? -3. -3 times x is -3x. -3 times 2, -6. When you draw the line, change the signs. So this has a remainder. We've gotten to the end of the polynomial. The remainder is -2. We call this the quotient, the answer when you divide. So my quotient is x minus 3. My remainder is -2. All right. Still using long division. What do you multiply x by to get x squared? X. Take x times x is x squared. X times 2 plus 2x. Remember, you're always taking this, distributing it all the way across. When you draw the line, change the signs. The front part should always cancel. -2 and -2 is -4x. Bring down the -8. What do I multiply x by to get -4x? -4. Take the -4, distribute it all the way across. -4 times x, -4x. -4 times 2, -8. When you draw the line, change the signs. This goes in evenly. So my quotient is x minus 4 with a remainder of 0. Okay, synthetic division is always the way to go. This is an alternative strategy. Whenever this term is just x in the front here, synthetic is going to be an easier process. What synthetic does is takes out all of the variables, deals just with the numbers, and then puts the variables back in at the end. So you always choose the opposite of this number and put it in a box. Then I want the coefficients from each part here. X squared, the coefficient is 1. The x, the coefficient is -1. And the constant is -8. Leave a space, then draw a line. This is the part that actually isn't too hard once you learn it. The first step is to take all the x's out and write the numbers across here. All right, then we're going to take the first number and put it below the line. Then take the corner number, multiply it times the number on the bottom, write it above the line. Add the columns together. -1 plus -2 is -3. Repeat the process. -2 times -3 is +6. -8 plus +6 is -2. Always put this last number in a box. That's your remainder. This is division, just like long division, but it's a different way to do it. And it's a whole lot easier. Now, we took all the x's out when we put the coefficients here. Now we're going to put the x's back in to find the quotient. This is my constant, and this is my x. My quotient is 1x minus 3. The last number is always the remainder. The next number is always the constant, and then you just start moving your x's up. We call this part here the depressed polynomial. The depressed polynomial is just the quotient when you divide, what you're left with here. We're going to do a lot of stuff with this coming up. All right, determine if x minus 2 is a factor. You can either use synthetic division or long division. Whether it's written as with a divide sign or with a fraction bar, that both of them mean divide. I'm dividing by x minus 2, so what number goes in the corner? It's always the opposite of the number, so we're going to put in a +2. Then I'm going to take the coefficients, only the coefficients, and they're going to go on the same line as my 2. Leave a space, draw a line. Drop the first number down, 5. 2 times 5, 10. Add 7. Repeat. 2 times 7, 14. This number is always what? That's the remainder. The remainder is 8. What's my quotient or depressed polynomial? Constant, put a plus in front of it, and then I need an x. 5x plus 7. Determine if x plus 10 is a factor. Oh, so back here, I forgot about that. Is x minus 2 a factor if there's a remainder, not a factor? Very important. The only way it's a factor is if there's a remainder of 0. All right, I would always use synthetic unless you're told to use long division. X plus 10, I'm going to put -10, always the opposite of the number with the x. Then I need all the coefficients. So x to the third is 1, x squared, 6. The x is 45, and I always need my constant at the end. Leave a space, draw a line. drop the 1 down below the line, multiply, add, multiply, add, multiply, add. Look at there. The remainder is 0. Therefore, x plus 10 is a factor. Okay, so if it is a factor, find the other factors. So what I'm going to do, I'm going to put my x's back in. So where did this negative 10 come from? X plus 10. Now, this is my constant. This is my x. This is my x squared. So it said, find the other factors. This is one factor. How can I find the factors of what's left over? Break apart your x squared, x and x. What comes next? Factors of 5 that subtract to get 4. 5 and 1 minus 5 plus 1. It says write the polynomial as a product of its factors. These are the 3 factors of the polynomial. That should make sense because my degree is 3. I would expect to have 1, 2, 3 factors to match the degree. Okay, we're going to do the same thing. It says determine if x plus 3 is a factor. So if we're looking to see if x plus 3 is a factor, I'm going to do the opposite of x plus 3 and put negative 3 in the corner. Bring down my coefficients. 1, 9, 23, 15. Leave a space, draw a line. See if you can start this on your own. How far can you get? Bring down the 1, multiply, add, multiply, add, multiply, add. Remainder is 0. Therefore, it's, well, I'm going to be better about this. X plus 3 is a factor. All right, so let's keep going. Let's put the x's back in. The negative 3 goes back to x plus 3. I think it's always helpful if you start with the constant. This is the 6x. The 5 is positive, so I just put a plus in between, and the 1 is x squared. So you're turning these coefficients back into your x's. Then we just need to factor our depressed polynomial, bring the x plus 3 down, break x squared into x and x, factors of 5 that add to get 6, plus 1, plus 5. So this polynomial, this is a set of linear factors that represent this polynomial. So I'm just going to put g of x equals that in front. So what that is saying, if I need to put this into factored form, this is how I do it. We're given one factor, we use synthetic to find the rest of it. All right, so how can we figure out, is x minus 1 a factor of that polynomial? Now I'm just going to let you do that one on your own.